Hey everyone, Colin Pause here. In this video, we're gonna take a look at a really good question called Sunflower. It's a Junior 4/Senior 2 question from 2018 CCC competition. But before the video start, I just want to quickly mention that Coding Pulse still offer courses for Java, Python, and Scratch. We're still having few spots for intermediate Java class. And I think that class is really helpful because we do offer valuable information for CCC contest and AP Commerce Science A. And so every technique we're gonna use in the videos are included in the course outline. Okay, let's go back to our question. So I firstly gonna read the question. Barbara plants n different sunflowers, each with a unique height, ordered from smallest to the largest, and records their heights from n consecutive days. Each day, all of her flowers grow taller than they were the day before. She records each of these measurements in a table, with one row for each plant, with the first row recording the shortest sunflower growth and the last row recording the tallest sunflower's growth. The leftmost column is the first measurement for each sunflower, and the rightmost column is the last measurement for each flower. If a sunflower was smaller than another when initially planted, it remains smaller for every measurement. Unfortunately, her children may have altered her measurement by rotating her table by multiple 90 degrees. Your job is to help Barbara determine her original data. Input specification. The first line of input contains a number n. The next n lines each contain n positive integer, each of which is at most 10 to the power of 9. It is guaranteed that input grid represents a rotated version of Barbara's grid. Output specification. Output Barbara's original data consisting of n lines, each of which contain n positive integers. So you can pause the video and read the question by yourself or just try to solve by yourself. But I will just explain my thought and my solution. So basically the question is giving you a rotated version of a set of data, and you gotta make it back to where it was, where it is initially. So there are a few things that we need to pay attention. Okay, the first thing is first row recording the shortest sunflower's growth, and the last row recording the tallest sunflower's growth. So it's kind of like sorted. The first row records the shortest one, and the last row records the tallest one. And there's like it confused me at first. So it wasn't the biggest growth; it's the tallest sunflower's growth. And another thing is, if a sunflower was smaller than another when initially planted, it remains smaller for every measurement. Okay, so I think I should give you a more detailed example to explain this. Okay, let's say, oops, let's say we have like the shortest one is 1, initial height is 1, and the second one is like 3, and the third one is 4 maybe. And because it is growing taller and taller, so it will always be bigger than the initial number, like 1 or 3 or 4. So let's say 2, 4, 8, 9, 11, 19. So because it is growing higher, it means this part of the table is always bigger or higher than this part of table. And because uh, the first row contains the shortest flower, and the last row contains the largest flower. It means uh, on the first column, the second or beyond those like third or until the last column. Sorry, until the last row is always bigger than the first column. So in another word is our left top left top height is the smallest. So no matter how it rotates, it may rotate like uh, like what? Yeah, like 1, 3, 4, 2, 4, 8. Okay, if it rotates this way, we can still figure out uh, the life top from the original one and it's here. And all we need to do is like reverse it, or we just print the data in this way. So it will be printed like the original version. 1, 2, 4. We print it in order, and 3, 8, 9, 4, 11, 19. So in our program, after we scanning all the input, we're gonna look for, while we are scanning in the input, we are gonna look for the smallest value. So the smallest value will be the key of determining how many turns it has rotate, or where's the top left data. So in this case, it is here, and we can just print the rest like this. And there's another thing that we need to uh, know is, because no matter how you're gonna rotate, how many times you're gonna rotate the plot or sorry the data, uh, the top left data can only be in top right, top left, bottom left, and bottom right. So all we need to look for is these 4 points, and that's it. Let's go to our IDE and code the actual program.
Okay, so welcome back. So for our code, I firstly create a scanner to scan all the input like always, and I create a 2D array called data to store the values of integers of the chart. So the rotate chart, not the original chart. Uh, and we're gonna create a number called the smallest value. So I create an integer field called smallest value, and it will initially be the max value of the integer. So anything smaller than the maximum value can be captured. So we're gonna use a for loop to store, or sorry, to take the input one by one, and each time we are taking an input, we're gonna check if it's smaller than the smallest value. If it does, we can update our smallest value to that value. So after we run through this for loop, we're gonna get the smallest value. So remember how we're gonna locate how we're gonna determine how many times we have been rotated is through the smallest value. If the smallest value is at the top, it means top left. It means they haven't changed anything. So we can just print the um, print the chart in the original order. Sorry, I select the wrong thing. It is here. So if it's at the top left, which index is 0, 0, it means it haven't changed the position. So we're gonna just use two for loop to print. And so in each row, we are not actually starting a new line every time after we print a number. So we are not gonna use print line. We're gonna use print, and add a space after each number. So what is the smallest value is at the top right. So here, then how we're gonna print it is we're gonna print it column by column. So as you can see, the last column here contains the result of the first row. So we're gonna print column by column, and in each iteration, we're gonna increase our rows number. So it will print 1, 2, 3, like 1, 2, 3 by the order. And wait a second. So here. So how we're gonna print it is print column by column, and row are increasing. So it will be 1, 2, 3, and between them there's a space. And after we print a row, like a column in the original format, we're gonna decrease the number of the column, so it will print this column. And still by the same law, row increases, so it will be like 3, 5, 7, and this one is 4, 6, 9. So in our code, the outer layer is column because the output of the row each row of output is each column of the data. Okay, but what if the value is at the bottom right? So so it will be like, this is really, really messy. I hope you can understand this. So what if the smallest value is at here? We're gonna print row by row in decreasing order, and column by column. Sorry, we're gonna print column by column, then row by row. So each row of the result, each row of the output is a row here, but it is all in decreasing order. So the first column of the result will be the last column of the input or the data, and the first row of the output will be the last row of the input or the chart. So that's where I just trying to here make everything backward, print everything backward in this order. So here, and then we're gonna print by this way. In the final scenario is our value is our smallest value, let's call it S3, is at bottom left, which means I didn't use else if because it is left at the bottom, which it is just what left behind the honest scenario that left. So in this case, the column will be 0, and the row will be num -1. So let me just create n -1. So this is the index. So if the number here of the original chart equals to the smallest value, it means that is in the scenario. And how you gonna print is row by row in increasing order. And sorry, we are gonna print column by column in an increasing order and row by row in a decreasing order, because the one gonna be on the top, so we're gonna print this one first, this one last, but this column first, this column last. So let's try to run our program with some sample. 1, 2, 3, 3, 5, 7, 4, 6, 9 works. This one, yeah, this one works as well. So let's try to run our code in the DMOJ. Oops. And print. Okay. Every test case passes. It means we are right and our program is working correctly. So I want to do some final conclusion of this question. So after I solved this question, I viewed other solution on the website. So I noticed some people actually trying to rotate the chart back into the original format, but I think it is actually kind of overworking. We can just print it in the right order, and that's fine. Just I think rotate it into the correct order is kind of confusing, and it requires a lot more work, in my opinion. So the key to this question, I think, is to use the smallest value to determine what position it has been rotated to. I think it is really important, and if you get that, you basically can do this question. And others details is just how to print it, and just print in the right order, and you will be fine. Okay, I hope you learned something from this video, whether it will be just basic program language or some algorithmistic skill. Thank you for watching. As always, bye. But be sure to check out our free programming courses on our website. Bye.